How do I feed it? So, yeah, I don't know. I think you might have to.
Hey, Jeff.
Hey, Daniel.
How's it going?
I'm doing good. How are you?
All right. Getting a little tired of Zoom. Or just like, 1 second, the audio cut out. What happened?
I can't hear you.
Oh, yeah, I can faintly hear you. Oh.
Hey, Madison.
Hi, can you hear me? Sorry.
Yeah, I can hear you fine. Hello.
Hi.
Let me get all my stuff.
But it sort of sounds like.
Sorry, I'm just getting my document, my sharing documents up. And then,
Hey, Madison. Have you gone on to the online math lab thing yet? Just
I
wondering.
did look at it. I haven't scheduled anything yet, though.
Okay, it's all drop-in, so you don't need to schedule
Okay.
it. But
Okay.
I'm just wondering, yeah, because I've been incredibly not busy on there.
Okay.
So I'm just like, I don't know if people are having issues with it or whatnot, but that, and also like if you ever have a question too.
Okay.
Right, are you in the group me chat?
Yeah, I think so.
Okay, yeah. If you ever have a question and want like an explanation like with a person, not over text, just let me know and I can hop on Zoom like really fast.
Okay. Okay, great. Thank you.
hello,
Yeah.
Seema.
Hi.
Okay, Daniel, your lighting is terrible. Daniel, could you close your curtains? I actually can't see you.
I'm moving actually, so.
Okay.
Because
that's so much better. Okay. All right. So this was intended to be about just the stuff that we didn't have any Zoom meetings about: two-sample hypothesis testing and chi-square. And so if you wanted to ask questions, that's all this was. It's just basically office hours, just for you guys to ask some questions.
Okay.
I wasn't gonna, talk about anything specific. Hello again, Hazel. Nice to see you again.
Hi.
Oh, you moved.
Yes, I did it.
Yeah, so, but that's really all it's for, is just if you wanted to ask some questions on chi-square or two-sample. I've got the worksheets open. I've got the book open. You can ask whatever you want. Right, so there's it's my, get that over here. Two-sample worksheet. And the chi-square worksheet. That guy. And those are, yeah. Have you guys all finished the homework on this? Those are the ones that I haven't got to yet to put in the grade book. But if you wanted to ask homework questions, you're welcome to. If you wanted to ask general questions, you're more than welcome to.
I have a question from homework, question number 121.
Which chapter?
It's like the 11.
11. All right. So let me share that. Okay. That group chat is, or the chat's right in the way. All right. So, whoop, come here. There it goes. Chapter 11. Oh my gosh, come on. 121. Was it 121, Asima?
Yes.
Okay. Plant manager is concerned her equipment may need recalibrating. Seems that the actual weight, hello, Matt. Seems that the actual weight of the 15.5-ounce cereal boxes it fills has been fluctuating. Standard deviation should be at most 0.5 ounces. In order to determine the machine needs to be recalibrated, 84 randomly selected boxes of cereal from the next day's production were weighed. The standard deviation of the 84 boxes was 0.54. Does the machine need to be recalibrated? So what I'm hearing there, so okay, so let me just type this. I think that would probably be easier. I tried writing it, and that was just a giant mess. It didn't work at all. So Can I share more than one thing at a time? Where's my blank doc? There. All right, so I want to make a null hypothesis. Oh my gosh. That the machine doesn't need to be recalibrated, that the standard deviation is okay. And then if we see evidence that it needs to be recalibrated, then I want to recalibrate it. So my null hypothesis is going to be that the machine is fine. So they should have a standard deviation of at most 0.5 ounces. You can write that as like, sigma, that's gonna be a sigma in just a second, is 0.5 ounces. You can also do this, I suppose to be as precise as possible, I should do it like this, right? That is less than or equal to, oh my God, hang on. Sorry, this is, everything's, I have like a million windows open here. We want to do less than or equal to here, right? 0.5 ounces. So that's my null hypothesis, is that the machine doesn't need recalibrating, that the standard deviation is fine. And my alternative hypothesis is going to be that it does. And so I would have this. All right, but again, that's a sigma, not an S. What? Computer, hang on. Okay. Right, so we have those as our hypotheses. So the first thing you want to think is, what kind of test should I be doing here? Actually, I've gotten this way out of order, I'm sorry. The first thing I should have asked is, what kind of test should we do and why? And so that's I guess, the first question to answer, so go ahead.
Z-test?
I don't want to do a z-test because we are testing a standard deviation. And standard deviations aren't normally distributed, which is what we use z-test for. What are, so standard deviations are distributed, follow a chi-square distribution, which is why we use a chi-square test.
Are we doing a chi-square or true hypothesis right now?
Well, that's an excellent question. So the answer is that it's chi-square, but the way you can tell that is that they asked about the standard deviation of something. And so this is not a question about a mean or a proportion or something else. It's a question about standard deviation, and standard deviations follow a chi-square distribution, which is why we do chi-square tests when we want to know if something is more or less consistent or more or less variable. Right, and that's what this is about. So Maya, did you get that this was number 121 in chapter 11?
No, let me find that one.
Okay.
I have to go find my earphones.
Oh, okay. So because we're asking a question about a standard deviation, and our hypotheses are about standard deviations, we need to do a chi-square test. And we need to do a chi-square test of a single variance. This is about standard deviation, but of course variance is just standard deviation. So I want to use my, I want to use this formula. Let me get the right thing up here. This guy. It's like this one, right? It's like it's like number 8 on the worksheet, where we're testing a standard deviation, and so I want to use this test statistic right here. Chi-squared is n minus 1 s squared over sigma squared. Sigma comes from the hypotheses, the null hypothesis, because remember that whenever we're doing a hypothesis test, we start by assuming that the null hypothesis is true and go from there. So if the null hypothesis is true, then sigma is 0.5. And S is what we got from our sample. It was 0.54. So I want to calculate that, n minus 1 s squared over sigma squared. Come on.
Also,
Right, so I want to do this. So I can't show you because I'm not on. Oh, shoot. All right, I'm going to have to do this kind of the awkward way. So I'm going to have to do n minus 1 times s squared over sigma squared.
0.5.
Right, I'm gonna have to, that's my test statistic. It's gonna be chi-squared equals this, n minus 1 s squared over sigma squared. So in this case, n is 84, is that what they said? Yeah, where I have,
Is that the test statistic?
yes, it is. You can see that on the
So it's not
guy?
O minus C?
it's this. No. This is test of a single variance because we're testing to see if, so test of single variance is a test to see if the variance is what we think it is or not. Right, and so we are testing in this problem to see if the variance or if the standard deviation is 0.5, which is said the variance is 0.25. And so we're just following this basic chi-square distribution. So no, it's not
What
the O
would
minus C,
our
it's
n
different than
be?
the other ones. What's that, Hazel?
Oh, the n, because it's like n minus 1.
Yeah, n is 84, so n minus 1 is 83.
Yeah.
So I had n equals 84. S equals 0.54 and sigma equals 0.5, and that is a segment on S. And so we just plug those things in. So you just jam that all in your calculator and see what you get. So I'm gonna, I guess I can do that on Desmos. So I've got 83 times, and don't forget to square them. Squared over
96.8.
yeah, 96.8. That's what I got as well. 96.812 or 81. So the thing I get is that. So that is our chi-squared test statistic. Now that might look really big, but it's not actually. And the reason it's not is that the mean of this, one of the things to remember is that the mean of a chi-square distribution is equal to its degrees of freedom, which in this case is 83. So this is not actually all that big. We might, I don't know if we're going to reject the null hypothesis or not, but that's what we found. So what I want to do is chi-square CDF of that, chi-squared CDF. And because I'm checking to see if the standard deviation is bigger than 0.5, I'm going to be doing to the right. So I'm going to go chi-square CDF squared CDF of 96.81 to infinity with 83 degrees of freedom. What are you doing? Yeah, that's what I'd want to do. No, I can't do that. I don't have my calculator handy.
.1426.
Cool. All right, so with I've got 0.1426 is my p-value. So I want to compare that to alpha. So let's go back and look at the problem. No, not that one. Where's, there it is. Sorry. Whoop. We're behind a window here. I can't see anything. Okay, so it looks like Did they tell us an alpha?
There's no alpha.
There's no alpha given, so that means we should use 0.05.
Okay.
So
So p-value is
yeah.
smaller than alpha.
So when we look at this, is our, you can't see that because I didn't share it. So is our p-value here,
It's smaller than alpha.
it's not. Alpha's 0.05. This is
Oh,
14%.
It's not.
Alpha's
0.05.
5%. This is 14%.
Yeah.
Yeah. So
Oh.
this p-value is bigger than alpha. So which of these things do we think is true? Do we think that the standard deviation is less than or equal to 0.5 ounces or greater than 0.5 ounces?
Our standard deviation is less than equal to 0.5.
Yeah, we think the null hypothesis is true.
Yep.
And since we think the null hypothesis is true, that means that we don't think the machine needs to be recalibrated, right?
Okay.
Eres un Wi-Fi que sea mejor que Vines.
I'm sorry, I didn't hear that.
Me lo puedes hacer que
I'm sorry.
¿Cómo se llama?
Maya, are you saying something?
No, sorry, I'm trying to connect to the Wi-Fi because
Okay.
I can't. It's not
Could I ask you to mute yourself if you want to talk outside of this because it's distracting.
Yeah, sorry, I forgot.
No worries. So anyway, we got yeah, we don't want to recalibrate the machine. So my conclusion would be something like this data suggests the machine is working within normal parameters and does not need to be recalibrated. Right, something like that. That's it. Is this one of the ones where they were not where they have the evens as the answers? Oh, they did. They switched at 120. Are you kidding me? Okay. Sorry. Throws me off whenever they do that. So Seema, I believe you were the one who asked that originally. Did that help you? Like, did you see what I did there and why? Is there anything you guys wanted to ask about that? Sorry, it's muted and nobody's in chat either. Wait, is there? Where did my chat go? I swear my chat window just disappears.
No one's saying anything in the chat.
Okay, good.
So
H. Okay.
in all the cases, because then in the double hypothesis too, we just have to put all the values in the calculator and that's it.
Yeah, pretty much. Like that's really what most of the hypothesis tests are from here on in the class, or even from two sample to the end.
In the two sample, you never explained what it like how to get to the p-value like you did in the one sample, like in the notes.
Oh yeah, I did. Yeah, I can show you where it is. Here.
I don't know. I never got to
Yeah,
that.
no, I'll show you.
Okay, but then if we just put it in the calculator, that's gonna count. Like, is that a deal,
Yes.
right?
Yeah, did you read over the notes I put at the end
Yeah, I
here?
can take them and everything.
Yeah, proportions. What was there?
And then the homework and everything, we just have to keep sending it to you the same way we were doing before.
Yeah,
Just the picture of it.
Yeah, I really wanted to use what was it, My Open Math, but the questions they had on there were not very good, and to write my own I needed to learn HTML.
Okay.
And that like that didn't work out very well. I don't know HTML. So let me show you where I showed to do it.
No, I should have both.
Jeff, I've been helping a lot of people lately with OpenCamp, and it's so bad.
Oh, really?
Yeah. It's,
See, so I don't want to get off on too much of a tangent here, but it seems like it's promising. Like I can technically, if I have the know-how, write anything I want, but it's very difficult to make it work, especially with stats where there's a lot of graphing. Anyway, Maya, so this was where, like, to have your calculator do a 2-sample t-test, go here, stats test 2-sample t.
Yeah, that's, I know. Like, I found that in the calculator and I could do homework in 13. Like, I did that one and I sent it to you.
Uh-huh.
But then that's with the calculator. I don't know how to calculate it without the calculator.
Oh,
Like the p-value.
this. Yeah, like, well, you're not gonna be able to calculate the p-value without a calculator. Like,
Okay, so
you always
it's
need,
fine. It's fine. You don't
well, no,
need
it's gonna be, you need normal CDF anyway,
Okay.
right? But
Now
like,
wait, let's use my calculator.
yeah, you'd need normal or TCDF anyway. And you would do it like, if you want to do it by hand, it's like this. Which is not the worst, but that's how. What other questions did you guys want to ask about?
Oh, I just had a question about, I mean, it's not really anything specific. It was just about like, because for the class notes for linear regression, I was wondering if you already updated the page with the answers.
If I already updated the what?
The page, because it says here, like, I will update this page with worksheet answers in a day or two. I was just wondering if you have.
No, that's another thing I need to do. Cole asked me about that too, about the quizzes.
Okay.
No, I haven't put that up there yet, but thank you for reminding me. I forgot that.
Yeah.
Back here.
What else did you guys want to ask about? We can do 2-sample questions. We can do chi-square questions.
For me, I want to ask about like how to explain stuff because, like you said, the calculation part is quite easy. We just put it in the calculator.
Right.
It's like the explanation parts.
Right. So
any question is fine.
For almost every explanation, the thing you want to do is say the null hypothesis, or say whichever hypothesis you are supporting in words. So for instance, this guy, where'd it go? There it goes. Right, so here's what my conclusion is for this. Right, the data suggests the machine is working with the normal parameters and doesn't need to be recalibrated. And the reason I said that is because our conclusion was that we don't want to reject the null hypothesis, right? And so I don't want to think of the null hypothesis so much as sigma is less than or equal to 0.5. I mean, I do, like, that's correct. But the thing I really want to think of it is as the meaning, we don't need to recalibrate the machine because it's working fine.
Okay.
Right. And so that's all you have to say is like, we don't need to recalibrate the machine because it's working fine. Right. The variance isn't too high, so we're fine.
How about like for the 2-sample hypothesis 2, like for number 2 and 3, like from the
Number
notes,
2 and
like,
3, like on the worksheet, you mean?
Yeah. Yeah,
Let me start your page here. So. All right, so for 2 and 3, these guys. So, okay, so this is, I don't want to get too hung up on this because this is not a thing that is super critical for you to understand to do what we're going to do with the data. This is just an explanation of why the formulas look like they do, basically. But to answer your question, if we took a sample of, what is this, an A, so sample A is 25 and sample B is 36. The central limit theorem tells us that the sampling distributions of X bar A and X bar B would be the things that you would, like you just use a central limit theorem. So for A, it's just going to be normally distributed with a mean of 17.3 and a standard deviation of 3.5 over the square root of 25.
Yeah.
And for B, it would be normally distributed with a mean of 6.8 and a standard deviation of 4.1 divided by the square root of 36.
Mm.
And that's all it is in 2. There's no real explanations in 2.
Oh, okay. So can you do like one question for us, like number 6, I think, number 6?
Sure. Yeah, we can do 6. Okay. So we want to determine if there's a difference between the average height of American women and the height of Swedish women. Take a sample of 33 American women, taking an average of this, standard deviation of that. Same thing for the Swedes. All right. So let me get this going. All right. So for this problem, we've got whoop. Oh my gosh. Look. Look here, computer. All right, so I've got n sub a is, I forgot already. Sorry, I have so many windows open here.
No, it's okay.
I'm used to dealing with all of this. One sec. Oh, Zoom, go away. All right, where was I? Okay, n sub a was 33. N sub s, the Swedish women, was 21. I guess I could do this. U sub a is 65.4, and S sub a is 2.6. Oh my gosh. I had that same thing, number of Swedish women, the 60, so mu sub S is 64.3, and S sub S is 2.8.
S is
Mu.
standard.
This is X bar, right? So this is it's actually X bar sub S.
Oh yeah.
Sorry.
Okay.
I'm just gonna write it as X. It's hard to write. It's very hard to write bars.
Yes, it's
So
okay,
just bear with me here.
So like X bar and mu is the same thing, right? Like
No.
when
Mu
we-
is the population one.
Yeah.
No, mu is
Okay.
population.
Okay.
They're both means. It's just that it's the mean of the
Yeah.
sample
mu
versus
is-
the population.
Okay.
Right, and we can just jam this all in the calculator pretty easily. If you go to 2-sample t-test.
Two sample. Okay.
Yeah, if you go to 2-sample t-test in your calculator, this is what it's going to ask you about. Now, we do need to write hypotheses.
Okay.
Right, so my null hypothesis and my alternative hypothesis. Now, for our null hypothesis, so let's read here. So, oh, you can't see that.
Like, is it data or stats? Like when we input 2-sample t-test.
You're gonna do, so for when you're doing data or stats, you only do stats if you actually have, or excuse me, you only do data if you have raw data, if you have like a list of heights.
Oh, okay.
Right, and this is statistics because all we have are summary statistics.
Oh, okay.
So, I forgot what I was gonna say. Oh yeah, we're writing hypotheses. So we want to determine if there is a difference between the average height of American women and the height of Swedish women.
Mhm.
So there's kind of 2 ways to say that. I like the easiest way that I know of to say that is this. These are mu's. Mu sub American equals mu sub Swede.
Mu of Swedish woman.
That.
Okay.
Sorry, bear with me while I clean this up a little bit.
Yep.
Right. and then same thing, but with not equal to, right? Because we want to see if there is a difference or not. All right, and so this should just be a not, oh my God, everything is in the way of everything else. Should just be a not equal to. Right, we should have those for our hypotheses. And so when you do the test in your calculator, I don't remember what it comes out to be. I remember that you don't reject the null hypothesis here. Did you guys do this and get a p-value? What did you get for your p-value?
Like is it pooled or it says like after the new one not equal to
pooled
2?
or unpooled.
Yeah, pooled or unpooled.
So we're just always using unpooled.
Okay.
You can, I want to go off on a little bit of a tangent. If you can show that the standard deviations are similar enough to each other that it's reasonable to think they're from the same population, you can do a little bit of fancy math and make your p-value a little bit more precise.
Okay.
If you do pooled. But to do that, you really have to do what's called the two-sample F-test, which isn't, like, we don't even learn about that until the end of ANOVA. So for now, we're just doing unpooled. And I guess we'll probably just continue doing unpooled the whole time. I think that's the easiest way to do it. So unpooled, yeah, there's no real reason to think about it any other way.
If for number 72 and all those in the table, we have to put the values in the table here, right?
For number 72,
For
I don't know, probably. That's in chapter 10?
no, chapter 11. Like for the chi hypothesis.
Probably. Let me look at 72. I'm sorry, I'm not looking at it right now.
And then the exam, it opens on Friday, and when do we have to turn it in?
Sunday.
And it's gonna be like the last exam, right?
Yeah, I'm just basically giving you all weekend to do it.
Thank you.
Face value, frequency. No, for 72, that one's goodness of fit. So that one's a little bit different. Do you put them in a table? Yes. Yes, although I'm trying to remember how to use chi-squared GOF. I'd have to look it up. I know that, I don't have that handy on my computer here. What is it, when you do the chi-squared GOF, what does it ask you for?
I'm pretty sure chi-squared GOF, you need to put it in a matrices or
No, that's for independence and homogeneity. Chi-squared GOF uses lists.
Okay, it uses a list. Okay, yeah, but you have to put the data in the list, and then it all it asks for, I think, is just like list 1, list 2.
Well, no, because but then you have to put the expected in the other list, right?
Yeah, so you put the observed and the expected in list 1, list 2.
Right.
But
yeah, Maya, are you catching that? And so for this one, you have to figure out what the expected is going to be. And so if it's a fair die and there's 120 rolls, what proportion of each one would you expect to be, or what proportion of them would you expect to be 1s or 2s or 3s? Anyway, Maya, you there?
So I just have to fill that up.
Yeah, you have to put this into list 1 and then figure out what the expected values are and put them into list 2.
Can I do the rule of 3?
The what?
Like if it's 120 and then out of those 15 are 1s, can I do the 15 times 120 divided by 100? The rule of 3?
No, you're thinking of homogeneity or goodness of fit, or excuse me, homogeneity or independence, where you're using a matrix, which that's not the, oh, wait, 15 out of 120 divided by
100 is going to give you a percentage.
Oh, yes. Yeah, but no, don't do that either. Sorry, I didn't think what you were thinking of there. No, don't do that either. You're not looking for the percentage. The expected count, since this is supposedly a fair die, you would expect 1/6 of the 120 roles to be in each category. So, sorry, let me get back to the, lost my place there.
I don't know why, but when I put those in the calculator, it says like error domain. Hello?
Yeah, no, I heard you. Why would it do that? Are you doing 2 prop C?
Oh, no. Wait. I
You
think
should be
I
doing
pressed
2 sample T.
yeah. So it's supposed to be 2 prop C tests.
No. This is not a proportion. This is about means. Right, so we've got a test about the means. So we want to use 2 sample T test.
2 sample T tests. Yeah, I'm doing it.
Okay. Shouldn't
So
give you any domain
X1
errors there.
Yeah, it says like error domain.
That doesn't sound right.
And so like X1 is 33, 65.4, 2.6. Yeah, 21, 64.3,
Wait. X1 bar is,
30.
so which one are you using?
Yeah,
One?
okay. Yeah. Okay. I got it.
Okay.
I know what
Oh, that's what it was. You were putting these where for the ends.
Yeah.
Yeah, because it's expecting whole numbers for the ends.
Okay. Got it. Yeah, the p-value I got is like 15%. So
Yeah, that's not right.
to reject the null hypothesis. Right?
Yeah, that's not enough to reject the null hypothesis.
Okay.
Right, and so what would our conclusion be then?
So our conclusion will be the average height of American woman and the average height of Swedish woman is the same.
Yeah.
There's not enough to
Yeah, that's all I'd say.
That's all right. I'm missing it. Is there anyone? I don't know if anyone else wants to ask question.
So for the 7 to 2, is it going to be like a fraction? So it's going to be 15 over 120?
No. So for number 72 here, let me flip back so everybody can see what we're talking about. So for number 72, the things that go in the frequency and expected frequency are, so frequency is just the number of things you actually saw. Expected frequency is the number of things you expected to see in that category. So if I'm rolling a die 120 times, and the chance of getting a 1 is 1/6, then I would expect 1/6 of the results to be in this category, which would
But
be
how do
20.
I know that 1/6 is the amount of times?
How do you know that 1/6 is what?
Like, how do I get to 1/6 in the expected frequency?
So you have to think about what percentage you're expecting to see in each column. Now, for goodness of fit, most of the time, what you get is something like this. Let me flip back to my chi-square. For goodness of fit, most of the time, what you get is something like this, where you have a hypothesized percentage for that category. All right, so here we have an old study that says 37% of people have, or of Americans have blue eyes, right? And so that's the percentage that you're expecting to see in the blue category. So I would expect that 37% of the 300 people that I interviewed would have blue eyes. Now I actually saw 97, so 37% of 300 is 111. Now I actually saw 97, right? Those are two different things. But the way I'm calculating it is what percentage I expect to be in that category times how many people I surveyed, or times, sample size. So when I go to the thing you're talking about, if I've got a fair die and it's got 6 sides, what percentage do I expect, or percentage or fraction do I expect to fall in each category?
1/6.
1/6. So there are 120 roles. It tells us there's 120 roles here. So I would expect that 1/6 of those 120 are going to fall into each category. Right? So I would expect, so a sixth of 120 is 20. So I would expect 20 in each category.
So should I put 1/6 times 120, and then for each one it's going to be 1/6, right?
Yeah, for each one it's going to be one. It's the same for all of them in this case, because all of our expected percentages are the same. That's not always true, but it is true here.
Halfway the die. So for all of them it's going to be 20?
Yeah.
And then I do the the formula, let me find the formula. O minus E squared over E.
Yep. Yeah, you do this thing. In this case, 6 times. Right, a little bit tedious, but not too bad with 6. Right, so you'll have for the first one, 15 minus 20, quantity squared, all over 20. And then for the second one, 29 minus 20, quantity squared, all over 20. You just repeat that.
But actually, that's 1, 2, 3.
Jeff, so the expected frequency will have to be calculated by the formula that you said, O minus E squared by E?
No, the expected frequency is, so it depends on what kind of test you're talking about. If you're doing goodness of fit, it's going to be, here, let me share this screen here. So if you're doing a goodness of fit test like this one, you're going to have a null hypothesis of proportion of 1s is 1/6, proportion of 2s is 1/6, proportion of 3s is 1/6, etc. Right? So that's literally what your null hypothesis is going to be, is just a list of six proportions. Then the way you calculate the expected frequencies is you take that expected proportion and you multiply by the sample size. Right? 1/6 of 120 is 20. 1/6 of 120 again is 20.
Now that I have all the little values,
You add them all up. Yep.
Yeah, so sorry, my Wi-Fi keeps going off.
and now
And once you've added them all up, then you want to do
the X squared CDF.
yeah, do chi-square CDF of whatever you got to infinity.
So Jeff, can you say that again? My Wi-Fi went off.
Sure. So once you here, let me switch this here to this. What we want to do is this. Oh no.
When I go to tests,
Uh-huh.
the option when I go to X squared GOF test, what it tells me is to put like the observed, the L1, and then the expected, which is going to be L2. That's why I asked about the table. And then the
Right.
degrees of freedom. And it doesn't let me put like X to the F, like this thing that you just told me to put.
So your list for observed should be 15, 29, 16, 15, 30, 15. And your expected should just be 620s.
And then I can calculate that.
And then degrees of freedom, in this case, is 5. It's one less than the number of categories. Gosh darn it. So, Seema or Madison, did you guys have anything you wanted to ask? I know, Seema, you asked the first question, but I don't, nothing since.
No, I think I'm good. I just kind of wanted to come on just to see what everybody else is kind of saying.
Okay.
If anyone doesn't have a question, I think I want to go over like the problems on the notes.
Sure, which one?
Let me see. Wait, just a moment. I think for chi-square, the wait.
Do you want to do independence or homogeneity? Or we just did a goodness of fit. Did you want to do one of those?
Just a moment. Yeah.
Do I have to write a hypothesis, even if it doesn't ask for one?
In general, you should, yeah. If you're going to do a hypothesis test, you should definitely write them down.
I want to do the table one, like
Like one of these guys?
Yep.
Okay. So if you're looking at the notes, the one, like the way I did the table one was that was the thing I did in the notes.
Yep, that one.
Okay. So let's look at it then. Where's my table? Here's my table. So if your question, so the sort of question that you get for something like this is, does a person's favorite ice cream type depend on their age and or gender? Right. So that's really what we're asking is, are these two variables, favorite ice cream type and age and gender, are they dependent or independent? And so you want to start by writing out you want to start by, I usually just write those in words.
Yeah. Okay.
I hate it when it does that. My null hypothesis is that they are independent, and my null hypothesis, or my alternative, is that they're dependent. So my null is favorite ice cream type, and age, gender are independent variables. And the alternative is that they're dependent.
Okay.
And then this is where it gets both easy and hard, in the sense that, like, the actual stuff we do is really simple. You're just going to put that thing in a matrix. You're just going to put the table in a matrix and then hit chi-square test. And yeah, that's really about it. If you want to understand why you're doing that, that's actually complicated. And the thing that I explained in the worksheet. So what did you want to know from there? Hazel,
Oh, yes.
what did you
I
want to
wanna
know
know
from?
how to put, like, how to calculate the matrix.
Okay, so the way you put it in a matrix is like this. Okay, so you want to hit the matrix button on your calculator.
Okay.
On your TI-84, it's the second function of x inverse.
Yep.
And then you'll get to something where it says names math edit, and it just has A, B, C, D, E, F, etc. Go over to edit.
Okay.
You don't want names, you want edit. Pick matrix A, or whichever one you want, but A is the default.
Yeah. Okay.
And then you want to type in that matrix. So that matrix is 4 by 5 because it has 4 rows and 5 columns. Whoop, lost Hazel again. I'm pausing here because I'm pretty sure Hazel lost Wi-Fi connection. I wonder if she's back in Myanmar.
Sorry, my internet went off.
I know, I paused. I saw that your screen had gone blank.
Yes.
So anyway, we're on matrix.
Yeah. Okay.
You hit enter on A, and it says 1 by 1 and has one little square for you to put things in.
Mhm.
So you have to tell it how big a matrix you want, and it's rows by columns. So I have 4 rows, 5 columns, so 4 by 5.
And then we don't count the
totals.
total. Okay.
Correct. Yeah, don't count the totals.
Okay. 25, 23, 11.
I'm enjoying the tour of your house, Daniel. Whoop. Hazel's not even listed now.
I was on mute. Sorry.
No, I know. Yeah, I saw you've been
Glad you like.
been making food for a little while and just listening in, which is fine with me.
Hey, yeah, I make guacamole while you're going over it.
We lost Hazel, and she was the one asking about this. So I will wait for her to come back and see. Oh, she's part of the way back.
Question was just about how to do the matrices in the calculator.
I think so.
Okay.
Right. Yeah, sometimes it's nice to be talked through it. Although I did write it in here. Maya, did you have anything else you wanted to ask while we're waiting for Hazel to get back?
So for number 74
Uh-huh.
on the homework,
Yeah.
we have to use the table above it, table 11.37. Is that it?
I'm looking. Perform goodness of fit test to determine whether the local results follow the distribution of the U.S. overall student population based on ethnicity. Yes. Yeah. So
Can we do that one together?
sure. So I would. So let's start here so I can point at stuff. Okay. So we're looking at this question here. Right. So this is about a. Let me do the whole setup here. Where is it? Columns contain the race, ethnicity of U.S. public schools overall, the percentages for the advanced placement examinee population for that class, and the overall student population. The percentages. Wait, race, ethnicity. Okay.
Yep. Sorry.
Suppose the right column.
I have followed the instructions up to
Your audio is cutting out too, Hazel. Hang on one second. I'm helping Maya with this this chi-square question.
Okay.
Suppose the right column contains the result of a survey of 1,000 local students from that year. Okay, so we have, this is the local students, and this is the overall student population, and this is the AP examinee. Is this, so the right column contains the results of a survey of 1,000 local students from that year who took the AP exam. Okay. So this is the ethnicities, or the counts of ethnicities of the 1,000 local students who took the exam, or took the AP exam. This is the overall student population breakdown. And then this is the overall AP student evaluation breakdown, the AP exam student evaluation breakdown, or student breakdown by ethnicity. So they want a goodness of fit test to determine if the local results follow the distribution of the US overall student population. So in other words, do these counts, the ones in the right column here, match up with these percentages? So these are going to be your observed. Wait, is Maya here?
Yeah.
Oh, there. Oh, sorry. There you are, Maya. I don't know. I apologize. I just lost your picture for a second there. Yeah. So there you go. So these are going to be your observed, and then these are your expected percentages, right? And so we said that there were 1,000 people in this column. So my expected count. How would I find the expected count?
By multiplying 5.4 times 1,000.
Yeah, 5.4% times 1,000, which would give us 54 students, right? Yeah. Right, so we would have an expected count of 54 here. We actually saw 113, right? So there's expected, there's observed, right? You do that for all of them. All right, so while Maya's doing that, Hazel, what did you want to ask about? So you said you were, you follow the instructions up to here. Hazel, you're muted.
Sorry, I've done up to the chi-square test, and then
Okay.
it says like observe and expected, right? Like what
Yep, like
does
this.
those mean? Yep.
So it's saying, what it's asking, this is actually, they're asking you two very different things. Interestingly here, observe, they're asking you, where did you put the observed counts, which you probably put them in. And what it's saying with expected, it's not asking you to calculate the expected. It's asking you to tell it where to put the expected.
Expected. Okay.
And so if you put, whatever you have in B, it's going to delete it here and then write over it with the expected counts. Then you calculate and you get this.
And calculate and got it. Yeah. Mm-hmm.
And if you wanted to look at the expected counts, you can actually do that. You just go edit matrix B, and you can see what all the expected counts are. You don't have to though; it's not really part of the problem.
B. Wait. or edit matrix B. Yep.
Yeah.
Oh yeah, they give me the values.
Yeah, exactly. The calculator, it finds them and makes a matrix for you. You don't
Okay.
need them for anything, but
Okay.
if you want to see them for some reason, you can.
Okay. 1 point. So like a significant level 5, can we say the, so I think, yeah, we can, P value is bigger. So we can,
You guys tiny.
independent. Independent mean, the independent mean, is it,
So they're dependent.
yeah, dependent, yeah.
Yeah, because we've got the alternative hypothesis is that they're dependent, and the null hypothesis is that they're independent. And so
Yeah.
the p-value that we got, right? P-value equals, what's that? 0.675, right? Something like that. So we want to, yeah, reject the null hypothesis.
Okay.
Right. Here's that. Type dependent. You also write it, a little bit differently if you want.
Okay. So how about for the second question? Like the second question, it asks, like, can depend on age? Does it depend on gender?
Right. So this was a thing that we were going to go over in class, but the way you want to think about this is, well, I have, wait. Oh yeah, sorry, number 5 here. That's why the star is here. This is supposed to be like a think about a question in class. If I want to know if it depends on age, what I can do is remake my table to have just like kids and adults, right? And so for the kids, I would take the boys and girls and combine them into one group, and for the adults, I would take the men and women and combine them into one group. So I would have a
Then we would have like two matrices, like.
Yeah, you'd have a new matrix. Yeah, you'd make a new matrix with right, instead of men and women, you'd have adults, and they would have 73 for cup and 59 for cone and 40 for sundae, right? I would be just combining these.
Yeah.
Just adding them together, right? And then for kids, you'd have 34 and 50 and 111, right? And you do the same test again.
Okay.
And then for gender, you can do the same thing, right? You just group up the women with the girls and the men with the boys.
Okay. Yep. Does anyone have any other questions to ask? I don't know.
Hazel, you're all the way back home in Myanmar?
Yep, I am.
I was wondering about that. What time is it there?
It's 9 a.m. now.
Okay.
So like when you first started class, it was 5 a.m. for me.
Oh, I'm sorry. I was thinking, gosh, it looks like Hazel's wearing her pajamas. I wonder why she didn't. Then I realized, oh, it's probably because you're halfway around the world. That's probably why. Yeah.
I have my math class. I have my Korean class at like 2:30 a.m. or something.
Oh my gosh.
Yeah.
I'm so sorry. That's so much harder.
Yeah, it's okay. Yeah. If other people doesn't have question to ask, I want to know like one example about the homogeneity.
Homogeneity.
Homogeneity. Yeah.
Yeah. So homogeneity, like from a practical standpoint, is exactly the same thing as independence tests. In fact,
Okay.
a lot of books don't even call them two different things. They just call them test of association and just do the same thing twice.
Oh, okay.
And so mathematically, we're actually not doing anything different at all. It's literally the exact same thing. The only
Same thing.
difference is that you have slightly different hypotheses, and
Oh, okay.
like you're thinking of, like, you're kind of answering a different question, but you're doing the exact same math to answer it. So there isn't like there's not much to explain other than what you're doing. But essentially, what you're doing is you're trying to see if two different populations have the same distribution of a variable. So for my example, I picked traffic accidents that involved alcohol and that didn't involve alcohol, and we wanted to see which ones, if they had the same severity of injuries. And so we just have 4 categories here, and we want to see if the proportion of accidents falling into each category is approximately the same or not.
Yeah.
And you do it exactly the same way, right? So I
Okay.
explain all the logic in here, but it's totally identical.
Okay.
Was that all you wanted to hear?
Yeah. And
For the test of independence,
Yeah.
for number 90, because I want to make sure I know how to do all of them.
Yeah.
Number 90 and 98, they're both of them test of independence, but those, we do those with
With a matrix.
With a matrix.
Yeah, those were the matrix. Those are like the ones that Hazel was just talking about.
Yeah.
So you said 90 and 98, right?
Mm-hmm.
So 90 breaks over 2 pages. That's annoying. Manager of a sports club keeps information concerning the main sport in which members participate and their ages. He wants to see whether there's a relationship between the age of a member and his or her choice of sport. Oh, this is a terrible way to do this. Why did I assign this wrong? Anyway, 643 members of the sports club are randomly selected. So we want to conduct a test of independence. And so they have 4 categories, right? 18 to 25, 26, 30, 31 to 40. Those categories aren't even the same width. Oh my God. Okay. And then 41 and over. And they want to see if age category is, or if sports and age category are related or not, right? And they have racquetball, tennis, and swimming are the only sports they've got recorded. So you just take this table, right? Not the category, not the totals. Did they have a total roll? They didn't put the totals. So the 42, 58, 30, 46, 58, 76, 38, 65. Like you put that all into into a matrix, and that matrix is going to be 3 by 4 because it's got 3 rows and 4 columns.
Wait, I can't see here. So I put that in the matrix thing.
Yes.
And I get there. Let me find. So I go to.
I'm sorry. Say it again.
Wait, let me find the matrix thing.
It's the second function of x inverse on the left side of the calculator.
And then I put 1, 2, 3, like all the ABCs is going to be each number.
No. So once you fit matrix, you go over to edit. Here, let me get this.
Okay.
So we want to do this, right? So we're going to matrix, edit. In A, this matrix is 3 by 4 because it's got 3 rows and 4 columns. So instead of like where I've got 4 by 5 here, you're going to type 3 by 4. And then you just put in the numbers, right? You put in the numbers in the table.
Okay, I lost your picture. Let's go here. So the numbers are
the ones from the table. Right, so the first row is 42, 58, 30, 46.
76. 35, 72, 60, 65. Okay.
And once you've done that, we're going to do this. We're going to go to stat and tests, and then down to chi-squared.
Is the wait? Where's guys? Sorry.
Right here.
Sorry, because I got a test. Okay.
Right, you enter, you get this screen.
And where did I put the B values?
You didn't put the B values anywhere. It's actually asking you two different things here. The observed is asking you where you put the observed. The expected is asking you to tell it where you would like it to store the expected. They'll calculate them all for you. You don't have to do it.
And now I just calculate it or draw it?
You can do either one, but I would do calculate. Right, draw will give you a picture of a chi-square distribution if you want it. And you should get something that looks like this.
Mm-hmm.
With a chi-square value and a p-value and a degrees of freedom.
Mm-hmm.
Right, and this was 3 by 4, so you should have 6 degrees of freedom.
Mm-hmm.
And what p-value did you get?
3.1159.
Times e to the what?
X squared would be
No. You said
e to the minus 4.
yeah. There you go.
Yeah, I forgot to read that part.
Yeah, don't forget that part. We need that.
Okay, and now?
Well, did you write your hypotheses?
No.
Okay, so you always want to start by writing your hypotheses. So it's going to be like this essentially, right? So for you, it's not, it wasn't favorite ice cream type and age gender. For you, it was age and primary sport are independent, or age and primary sport, age and are dependent. Right, so something like that.
It's really simple, but it's hard to get there.
This is one of those things where it seems like there's kind of a lot to understand so that you know what you're doing.
You just
and
have
once
to
you,
know which function to use.
Yeah, that's why we practice, right? Yeah, I totally agree.
Age and could I just put independent?
You should answer. So the way you want to answer your questions is always as though someone has come up to you and asked, is a person's primary sport independent of their age or dependent on their age? Right, and the way you'd answer that is like, pretend you were talking to them. Say something like, well, this data says that those things are dependent, that the sport they play depends on how old they are. Right, so you always want to think the way you're answering a question is as though you're talking to someone, basically.
So the conclusion is going to say that based on data, age and P is actually it's smaller than alpha. So,
Right. You said it was, yeah.
so you don't reject HO.
No, you do reject. Small p-value means you reject the
Oh
number.
yeah, sorry, you rejected it. I better be a little wrong. Okay, so are dependent variables.
Right. I would put it like I wrote it on the screen here. Right. I would say something like this. Data suggests the person's primary sport depends on their age. Right. If you wanted to say this data suggests that primary sport and age are dependent variables, that's fine too. Means the same thing. I'm just trying to write it more conversationally.
Okay. And then number 98 is also like that. And then we did
I gotta look at
121. 121 is with the test of single variance. Is it
Yes.
also?
Yeah, that was the one we started off with. That was the one that Seema asked about at the beginning.
Yeah, we did that one. And then, okay, let me finish this one and I'm going to check 101 and see if I understand it.
Okay. Oh, we're already 15 minutes over. Interesting. I guess it's still recording, right? Or it's still, yeah, I guess it's still working.
Can you put back the one that we just did, please?
Oh, the results for the ones that we just did? Sure. All right, that's what I would do. Excuse me, hang on 1 second. Sorry, losing power there.
Now, to see if 101 and 105 are usually numbers.
Jeff, if this is for the problem like number 7, so do we have to put in raw data, like from the notes, number 7 from the notes?
Wait, I'm sorry. Let me catch up to where you're at. Which one was 7?
From kite test.
Oh, that's the second one from last, right?
Yep.
Yeah. Oh, so let me do this. So that's this. Higher than 10 points. Okay. I see. So I didn't give you the standard deviation, so you'd have to find it, right? You'd put that all into a list and use one variable stats to find the standard deviation.
Okay.
I think it turns out to be about 17.
So that's about it. Like we don't need to use like the raw data set anymore.
No, you just want to do this, right? N1 S squared over sigma squared, and so you have to find out what S squared is, right? So you gotta. Well, I'm sorry, Hazel. I didn't catch that.
Yeah. Put that in a list and then do one var stats.
Yeah. Yeah,
Okay.
that's right.
Yeah, so for 101,
Yep.
it's with the obtained value minus the expected value. It's the same thing as the chi-square, the basic one, right?
No, this isn't the basic one. This is a matrix one. So
For
this is
101?
Yeah. Yeah, neither one of these is expected. They're both observed.
Okay.
Right, we've got a row of observed from business and a row of observed from social science. And we're checking to see if there's a difference in the distribution of personality types. So in other words, does this distribution here match this one down here, which is what homogeneity does. You just check to see if the two distributions are the same or similar enough to each other. So yeah, you want to make a 2x5 matrix for this one.
So it's the same as we did for number 90, but with that data.
For 19?
Number 90.
Oh, 90. Yes.
Consider me right?
Yep, it is.
And then I just write these things, and based on that, I write my conclusion.
So keep in mind that you have slightly different hypotheses here, right?
Okay.
We're testing to see if the distribution of personalities is in business is the same as it is in social science.
And that's HO.
Yes. And then HA is that they're different they're different distributions. I bet this one doesn't come out to be significant. Right, do they have answers here? Yeah, that's what I thought. Cool.
Do you already have the scores for the last exam?
No, I'm still finishing them. I've got the homeworks pretty much done, but I got way behind on the exams. I will have them shortly. Hopefully by Wednesday, but I'm not positive I'll be done by then because I got a bunch of answer worksheets to do and those take a long time.
That's fine.
Also, Jeff, that's all I have to ask for now.
Okay.
So I think I'm gonna head off.
Okay.
I'm getting really sleepy.
I'm not surprised, Hazel, if it's 7 in the morning there. All right. Well,
Thank
see you
you.
later, Hazel. Nice talking to you again.
Bye.
Bye.
It's fine if I finish this by myself because I think like it's only the three of us, so I don't want to keep you guys. But
I honestly don't think you'll have any trouble. Once you can tell apart the different chi-square tests, each one individually is pretty easy. Like none of them are hard to do.
exactly, it's not that hard. I just wanted to check to see if I understand how to do everything.
Yeah, I think you do. Well, I tell you what, why don't you, if you need more help, why don't you email me again or just wait till Wednesday.
Right, and then Chloe wanted to like the recorded thing of this, so I think you're
Yeah,
gonna post
I
it.
am recording it. I need to learn how to put it on YouTube, but
Okay.
I have it
Oh,
recording.
you have to create an
adequately.
account and just post it there, I think.
Well, the SBCC has a YouTube account where they're asking us to put all the recordings. So I just have to find out how to put it up there. It's not too hard. They have a video on it. I just haven't watched it yet.
That's perfect.
And also, I'm going to be online on the math lab tomorrow from like 4 to 8, I think. So if you have a question, just go on there.
Yeah.
Thank you.
That'd
I
be
just have to finish this, and then what's gonna go in the test?
great. 2-sample, chi-square, ANOVA, and regression.
Okay, so I'm gonna ask Daniel for ANOVA and regression tomorrow.
Oh, we haven't been over ANOVA yet. That's next. That's starting on Wednesday. I'm gonna talk about it on Wednesday.
Okay.
ANOVA, my favorite. ANOVA and regression.
So then,
Alright.
are we having a Zoom for ANOVA on Wednesday at 3:30, 5:30?
Yes, at 3:30 to 5:30. That'll be recorded and online as well.
Perfect.
But if you could be there, that'd be best.
Yeah. Thank you.
All right. You're welcome. You're welcome, Maya. I take it you're done then. Asima, are you still there? You haven't said anything in a while.
Have a good night.
You too, Maya.
Yes.
Okay. Well, I'm gonna end the sharing. Asima, if you had anything else you wanted to ask, you're more than welcome to.
I think I have to go over with it. Then I will ask and
Okay.
I have to look
Well,
at it.
yeah, I want you to ask questions on Wednesday. We'll talk about ANOVA. It won't take super long to do, and then we can ask questions afterwards.
Okay, thank you.
All right. You're welcome, Asima. See you later.
Mm.
All right, Daniel. Thanks for stopping by.
Yeah, no, sorry. I've sort of haven't heard from you. I like stopped responding to a lot of my Canvas messages because I got inundated
Yeah.
for about
I can
a
see
couple
that.
weeks. and like where it was like I would clear it out and 2 days later I had 50 new messages and I was just like,
Yeah.
so, but
That's actually kind of what it's like being a teacher some of the time.
oh yeah, no, I'm like, I don't know how you're doing it. Because in the group chat, they'll like, a lot of times they'll message like, I haven't heard back from Jeff in a couple days, blah, blah, blah. And I'm like, he probably got the same message 8 times and is trying to address the situation all at once. And then instead of having to like explain it to, one person 50 times, like.
To be fair, they had a legitimate complaint. I went way too long between responding to things, but that aside.
But it's just like that. What happened to me for a few days where I didn't respond to the chat at all because I was writing a paper.
It's like, oh my God, what am I? Yeah, like.
It's like writing a paper while I also have to work and do all my other homework. And it's just, I'm just glued to my computer for 15 hours a day. And I just like,
couldn't take it anymore. Yeah.
Yeah, no. And I was just so burnt out. I was like, fortunately my other professors were like, I told them what was happening. They're like, oh yeah, don't worry about like turning stuff in late. I'll give you full points anyway, blah, blah, blah. Just cause I was like,
that's what I've been doing with the students in your class where it's just like, they're having trouble keeping up and they're like, I got a million things to do and I can get the homework done. Like, just give it to me later. It's fine.
It's also because my thing too is I fortunately like one of my housemates is just not coming back to Isla Vista the rest of the year, and he let me kind of use his room as an office.
Oh, that's nice.
Before I didn't have a desk and I was writing a paper and my 2 places to work were my couch and my bed.
Yeah.
And that's just already distraction. I'm already ADHD, so I get distracted really easily. But so on top of that, it was like my back would start hurting after 30 minutes, and I was just like,
oh yeah, you can't work in your bed. I'm sitting here in a recliner.
Yeah,
got that.
No, it's
my little reading nook. Yeah. Anyway, I'll let you get off the computer. It's great talking to you. Thanks for stopping by. Stop by to as many of these as you want to.
Yeah, no, definitely. It was good because I saw it was chi-square, and I was always like, because when I first learned stats, I didn't learn chi-square, and like I